Welcome back, students. So in the last session we dealt with the differences between mass and weight. Now let us do some problems based on that. Okay. So the first question is, you can refer your textbook for the question, page number 138, example 10.4. Page number 138, example 10.4. The question is, mass of an object is 10 kilogram. What is its weight on the earth? So mass of an object is given as 10 kilogram. Its weight on the surface of earth. To find weight, the formula is m into g. And we know that acceleration due to gravity on the surface of earth is equal to 9.8 meter per second square. Now substituting the value, we get it as W is equal to mg, that is mass is 10 kilogram, into acceleration due to gravity is 9.8. So you will get the weight of the object as 98 Newton. The SI unit of weight is Newton. So the answer is 98 Newton. Okay. Now the next question is example 10.5 on the same page 138 of your textbook. Page 138, example 10.5. Question is, an object weighs 10 Newton when measured on the surface of earth. What would be its weight when measured on the surface of moon? So when you measured an object, when you measured the weight of an object on the surface of earth, the weight was 10 Newton. You need to find the weight of the same object when measured on the surface of moon. And you have an equation that Wm by We is equal to 1 by 6, or Wm is 1 by 6 times the weight of the object on earth. You have learnt an equation like this in the previous session. So using this equation, we can find the weight of an object on the surface of moon. That is Wm is equal to 1 by 6 into weight of the object on the surface of earth is given as 10 Newton in the question. So substitute 10 Newton. So weight of the object on the surface of moon is equal to, on solving this you will get it as 1.67 Newton. So 10 Newton is the weight of the object when measured on the surface of earth. The same object is placed on the moon and measured its weight has reduced to 1.67 Newton. Hope the problem is clear. Now moving to the blue questions given in the same page 138. On page number 138 you have a set of blue questions. Of that questions, question number 2. Question number 2. Why is the weight of an object on moon 1 by 6th its weight on earth? We know that weight of an object on moon is 1 by 6 times the weight of the object on earth. Why is it so? It is because acceleration due to gravity on moon and on earth is different. Acceleration due to gravity on moon and on earth is different. Hence the difference of 1 by 6 times. Okay. That is the answer for the second question. Now moving on to the textual back exercises, that is question number 10. Question number 10, that is there in page number 144. Move to page number 144, question number 10. Question is, Amit buys few grams of gold at the poles as per the instruction of one of his friends. He hands over the same when he meets him at the equator. So, he bought gold from poles and he handed over the gold to his friend who is at the equator. Will the friend agree with the weight of gold bought? If not, why? That is a question. So, he bought the gold from the poles and he handed over the same gold to his friend who is at the equator. Will the weight be the same at the poles and at the equator? No, because acceleration due to weight completely depends upon acceleration due to gravity. We know that acceleration due to gravity at poles and acceleration due to gravity at equator are different. We have already learnt that. We know the equation that G is equal to Gm by r square, where G is the acceleration due to gravity and r is the radius. That is, acceleration due to gravity and radius are in inverse proportion. Acceleration due to gravity and radius are in inverse proportion. That means as radius increases, acceleration due to gravity decreases, and as radius decreases, acceleration due to gravity increases. They are in inverse proportion. So, radius of earth at poles is less compared to the radius at the equator. Since earth is not a perfect sphere, radius of earth at pole is less than the radius of the earth at the equator. So, at poles radius is less. We know that radius and acceleration due to gravity is in inverse proportion. So, if radius is less, acceleration due to gravity will be more. So, radius at pole is less. So, acceleration due to gravity at pole will be greater than the acceleration due to gravity at the equator. Since radius and acceleration due to gravity are in inverse proportion, if radius is less, acceleration due to gravity will be more. So, radius of earth at pole is less. So, acceleration due to gravity at pole will be more than the equator. Again, we know that W is equal to mg. So, if acceleration due to gravity is more, weight of the object will be also more. If acceleration due to gravity is less, weight of the object will be also less, depending upon this equation W is equal to mg. According to this equation, W is equal to mg. If acceleration due to gravity at a place is more, weight of an object placed at that position will be also more. If acceleration due to gravity at a place is less, weight of an object will be also less. So, at poles we have a greater acceleration due to gravity. So, weight at pole will be greater than the weight at the equator. So, there is a difference in weight at poles and at equator. At poles, the weight of the object seems to be greater than at the equator. So, according to the question, the friend won't agree because he bought the gold from the poles and he is handing over the gold to a friend who is at the equator. The weight will show certain differences when the object is kept at poles and when the object is kept at equator. At poles, the weight of gold seems to be more, and at equator the weight of gold seems to be less due to difference in acceleration due to gravity. Hope the answer is clear. So, at poles radius is less. So, acceleration due to gravity will be more. So, weight will be also more. At equator, radius is more, acceleration due to gravity is less. So, weight also seems to be less. Hope question number 10 is clear. Very important question. Okay. Now, moving on to question number 12. Question is, gravitational force on the surface of moon is only 1/6 as strong as gravitational force on earth. Question number 12 of page number 144. So, gravitational force or weight at moon is 1/6 times the weight of the object on earth. What is the weight in Newton of a 10 kilogram object on moon and on earth? So, you need to find weight of an object on moon and on earth given mass of the object is 10 kilogram. So, in order to find the weight of the object on earth, we have an equation mg, and we know that acceleration due to gravity at earth is 9.8 meter per second square. Already the value of mass is given as 10. Acceleration due to gravity is 9.8. So, weight of the object on the surface of earth is 98 Newton. Now, the weight of the same object when placed on moon is 1/6 times the weight of the object on earth. So, that is 1/6 into weight of the object on the surface of earth is 98. On solving, you will get the weight of the object when placed on the surface of moon as 1.6 Newton. 1.6 Newton. Using the equation Wm is equal to 1/6 into We, you can calculate the weight of the object when placed on the surface of moon, provided the value of weight of the object on the surface of earth should be known. And weight of the object on the surface of earth can be easily found using the equation W is equal to mg, where g is the acceleration due to gravity, which is equal to 9.8 meter per second square, and m is the mass of the object. Hope the problem part is clear. Please make sure that you write and learn all the problems. Thank you.